Click the bell icon to get latest videos from Ekeeda.
Hello friends, in the previous session we studied about what exactly lime soda process is, what are the different by-processes of it, and an introduction to the logic of it. Today we are specifically going to study the cold lime soda process. Cold lime soda process. In this method, calculated quantity of lime and soda are mixed with water at room temperature. Over here, the most important thing is that the water should be at room temperature, and that is the reason why it is known as cold lime soda process, because the water is cold or it is at the room temperature. The precipitate obtained is finely divided, and to coagulate the precipitate, a small quantity of coagulant such as alum should be used. So what exactly is a coagulant? A coagulant is something which is then mixed with water to get attached either with the precipitates or with all the colloidal impurities of it, and then it will form a semi-solid like structure which can be easily removed then. Removal of precipitate by filtration gives soft water. The process can be carried out by two methods, that is batch process or continuous process. We'll see both these processes in detail. The first process is the batch process. A calculated quantity of lime and soda ash is added to water in a large tank made up of steel plates. After thorough mixing, mechanical stirring is stopped and a small quantity of coagulant, for example let's say alum, is added to coagulate the precipitate of impurities. So let us see the reaction that is happening. I have Al2SO4 thrice plus 3Ca HCO3, the entire thing twice, giving me 2AlOH thrice, which is a precipitate, plus 3CaSO4 plus 6CO2. Pay careful attention to the balancing because it has quite many number of brackets. So over here, if I consider this bracket is thrice as well as twice. But if I consider this bracket is only thrice because I do not have any coefficient over here. So it is very important to pay focused attention on the balancing of it. Let us look at the balancing of it. I have Al twice. Over here I do not have Al at all. So the overall number of aluminium on the reactant side is 2. Over here also on the product side I have 2 Al. Now let us consider the number of S, that is the sulfur. Sulfur is not over here at all, it is only at this part, the reactant 1 part, and this sulfur is in the bracket of thrice. Therefore, I can consider 3 sulfurs on the reactant side. Let us see on the product side. On the product side also I have 3 sulfurs because this S is associated with this 3. So now let us see the number of oxygens. Over here I have O, 4 and 3. So this is nothing but 4 into 3. That is 4 3s are 12. Over here also I have 3 into 2, which is 6. And this 6 into 3, which is 18. 18 plus 12 is nothing but 30. So I have 30 oxygens on the reactant side. And over here on the product side also I should have 30 oxygens. Let us have a look. Let us look over here. I have O3 into 2. 3 into 2 is nothing but 6. Plus I have 4 into 3. 4 into 3 is 12. And over here also I have 6 into 2, which is 12. So 12 plus 12 plus 6, which is also equals to 30. So oxygens on the reactant side are equal to the oxygens on the product side. It is very important to balance your equations. Each and every element on the reactant side should be same to each and every element on the product side. After this we have 3Ca. Over here also we have 3Ca. Let us see the number of hydrogens. H is 2 and 3, which is 6. Over here also H I have 3 into 2, which is 6. So this is an overall balanced reaction. The precipitated impurities, that is sludge, settles down at the bottom of the tank. So I have all of this which will get settled down, and this 6CO2 is a volatile compound, so it will just go out of the water. The water is pumped out and allowed to pass through a filter unit of sand and coal. After filtration, the soft water is obtained. Now, why do we have to pass it through a filter unit? Because of the precipitation, all the precipitates are present. Maybe some amount of precipitate which is still present in the water that can be removed through this filtration. To complete the process, 2 to 3 hours are required. After removal of sludges, the tank is washed with water. The same procedure described above is repeated again to soften more quantity of hard water. Now we look at the second process, which is the continuous process. This process is a continuous and therefore time is not wasted during the operations. In this process, hard water and calculated quantity of chemicals, that is lime, soda, coagulant, are fed from the top into the inner vertical circular chamber, fitted with a vertical rotating shaft carrying a number of paddles. As the hard water and chemicals flow down, there is a vigorous stirring and continuous mixing takes place. The softened water, as it comes into the outer coaxial chamber, rises upwards. The heavy sludge settles down in the outer chamber by the time the softened water rushes up. The softened water then passes through a filtering medium. Filtered soft water finally flows out of continuously through the outlet near at the top. The sludge at the bottom are removed through the sludge outlet. Now let us see what exactly happens in this continuous process with the help of a diagram. So over here I have the entire diagram. It consists of a tank. So this tank has two inlets at the top. The first inlet is for the lime, soda and coagulant. These things are fed into the inner vertical circular chamber of the entire tank. Along with this, the water is also fed. Now this water is the impure water or the hard water which needs to be purified. Now how will this get purified? The lime, soda and the coagulant with the impure water will mix together. Once they mix together, the stirring takes place. Now if you see this is my stirrer. These are the different shafts of the stirrer. So these will keep on rotating and paddling water. So what will happen over here? From here I have my coagulant, from here I have my water. So this mixture and this water will mix together with the help of stirrer and it will keep on mixing. Once it keeps on mixing, what happens as the water slowly flows down? Over here I have nothing but my pure water, or I can say that this is my softened water. From the inner chamber, what comes outside is only softened water. So from the inner chamber, the outer chamber transition is nothing but hard water into soft water. Now this soft water is pushed up, and when it is pushed up, there is wood fiber filter. Now why there is a wood fiber filter? Because this filter will just filter out all the other impurities which are present in the soft water. So this is an extra measure or an extra step to remove all the other impurities which are present in that soft water. And once that is done, the filtered softened water, this soft water can also have some types of particles, suspended impurities or some types of other materials present in it. So now this can be removed through this. This is a sludge outlet which is at the bottom of the entire tank. Over here all the sludge gets mixed up and this sludge can come out through this sludge outlet. So the water, the softened water and the pure water comes out through this outlet, and all the impurities and the sludges come out through this bottom outlet. So in this video we studied about the cold lime soda process. We studied about both its processes, that is the batch process and the continuous process. Thank you so much for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda.